Good afternoon. First of all, I would like to welcome all of you to this session. My name is Uthman Khalifa, and I'm going to present a paper with the title Deep Learning for Environmental Robust Speech Recognition in the 7th Conference on Electronic Devices, Systems and Applications. This is my presentation outlines. I'm going to give some introduction, motivation, also some of the network purpose solution, and also I would like to highlight some of the results and end up with the conclusion. As you know, that the speech recognition means that the ability of machine or program or application to identify words and phrases in spoken language and convert them to a readable format can be seen. And this is the typical system. This is the input signal recognition system. I'm going to be recognized. Of course, the speech means that here the signal or analog signal produced by, and this is the traditional framework where we have the feature structure, then we have the linguistic decoding, which include the acoustic model, lexicon, and language model, and then we end up with the and also language modeling, and end up with the recognized word. Of course, there are so many applications in speech, and one of them the recognition, and also conversational agent, also speaker identification, and also emotion recognition, or what we call it extracting emotion and social meaning, and also text to speech, and many others. And the speech recognition could be categorized to three types: isolated word recognition, or connected word recognition, or continuous speech recognition, or sometimes they call it large vocabulary continuous speech recognition. And all of them could be speaker dependent or could be speaker independent. And since the deep learning issue involved, so this like to show the relationship between the deep learning, machine learning, and artificial intelligence, where the deep learning is just part of the machine learning, also artificial intelligence, and also there where we would like to focus, and the aim of that understanding high-level representation of data using a deeper structure or multiple processing layers, where we're going to have multi-layer or multi-head layer. Also, this deep learning can be supervised or can be unsupervised, or sometimes called reinforced learning, and where we have so many hidden layers. And the question, of course, could be why deep? So since the number of layer increases, means that more abstract features are learned, and they are tend to be more invariant to specific variation, and also the sub-layer performance in practice actually will be improved. And of course, in the meantime, the deep structure is going to be hard to train, or maybe time consuming to train, but since we have now high technology, so we have no problem for timing. The motivation of this work actually, the robustness, because the title we're going to have what means robustness here. In natural environment, target speech occurs simultaneously with other interfering sounds. Could be sound from anywhere. So the problem, the robustness, or sometimes they call it mismatching between training and test operating condition. So achieving robustness to various forms of interference, and so is one of the challenging tasks. And of course, this problem could be caused by many factors like the source, speaker, language, output, and so on. This is some of the network. I don't think I'm going to go through, but I highlight a few of them since we have the time. And this is the proposed solution. First of all, we need to prepare the data, and actually we use the two types of data. Which one the what's called open source data released by Google, and also this data contains 65,000 returns of 30 words, and of course we did them to training and also validation and testing. And this is the proposed solution where we include the convolution networking, and we have, so this is the layers, all these multi-layers, and I'm going to present the results with different layers actually, and this is where we have to train the words. Actually we can isolate the word, and we're going to use the convolution neural network, and this is where this is the result where we have the 13 layers, and you can see here this is the words yes, no, up, down, and so on, so, and we got the accuracy around 69%. But if we increase the layers from 17 to 17 layers will be more, and for 24 layers will be around 94. If you go increase 27 layers will be 94 plus. And this is where we deploy the system for normal, not the data, our data, like we record our own data. We achieve around 80% actually. And just to show you some of the deployed systems or deployed words here, where we do, and then here comparison between number of layers, where you have 9 layers up to 27 layers, and you can see the accuracy for training and the error, the accuracy, and then training error and the validation error also. Okay, we come to the conclusion. Actually, an environmental robust speech recognition is still being achieved, or still far to be achieved. The use of deep learning in speech recognition was analyzed, and proper deep learning association was identified. We used actually the convolution neural network with different layers, just to aim for enhancing the performance of the speech recognition system. And this study actually achieved up to 94.3% accuracy. That's it. Thank you very much, and waiting for your comment and questions. Thank you.